From intercepting missiles to orchestrating robots on a factory floor, tomorrow's systems won't rely solely on rigid programming. They'll combine machine speed with real time strategic decision making, once thought exclusive to humans. With STEELRAIN, I set out to demonstrate the power of reinforcement learning in driving that shift. I've built a very humble reinforcement learning demonstration in which an agent learns to efficiently intercept dynamic targets within a designated target engagement area inside a 3D physics driven simulation. The overarching design theory for this agent was that I imagined it to have a real robotic counterpart, and so any model I trained should be hypothetically portable to it. It was after I finished SteelRain and began working on the feature length video essay that I discovered this had a name: Sim to Real Robotics. And so none of this is particularly revolutionary in terms of academic contribution, but I'm very proud of it as a self taught passion project and first step towards building a career in this field. On the defense side, let's compare two coastal defense scenarios to show how instant information exchange and connected autonomous units can radically change outcomes. In scenario one, traditional command and control, an enemy aerial carrier deploys four drone swarms. Friendly radar and satellite data is collected, but it must be relayed back to command before human action is authorized. Soldiers then pass target information down to anti air batteries. Because the batteries know little more than what is outside its immediate observation, defenses fail to intercept a high priority missile that was just using the drones as bait. Now imagine the same attack with a networked AI directed response. This time, all sensor data from radar, satellites, and forward observers across the grid are instantly processed by a BattleNet AI. Each unit, with its local observation and trained policy, begins performing optimally. Critical details like trajectories, speeds, and threat priorities are distributed in real time across the defensive grid. Because critical information doesn't need to travel through human command structures, reaction speed is maximized. By the time the hypersonic missile enters the engagement distance, all anti air batteries are primed and leading the target. After the prioritized threat has been neutralized, they reorient to clean up the remaining swarm. The difference is clear. In the modern battlefield where milliseconds count, connected systems with multiple levels of AI and autonomous units will dominate. It's easy to draw the parallel to industrial contexts. Robotic workers can be trained to labor in mines or warehouses, and the effectiveness of the entire fleet can be multiplied by systems level AI overseer to orchestrate complex tasks where teamwork is required. But even before operations, reinforcement learning can be used in early strategic planning phases. As long as you can define a problem as a game, reinforcement learning can optimize it. Imagine a section of a car engine plant. Each machine occupies a fixed amount of floor space, costs a known price, and processes inputs into outputs. By defining the state as the current placement of machines, the action as adding, moving, or removing a machine, and the reward as actual dollars earned from throughput minus equipment and operational costs, you can train an agent with your particular constraints for budget and floor space to maximize profit or minimize cost throughput ratios. With tuning inputs from domain experts, we can run large scale simulations to optimize for any bespoke business objective. Whether you tackle whole floor layouts or individual robot tasks, reinforcement learning reveals efficiencies hidden from conventional optimization methods. The opportunities to expand this project are endless. SteelRain is just one turret agent unit right now. I'd love to develop more units, such as simulated radar, satellites, mobile units, or even the drone swarms to attack them, in the interest of working on a higher systems level AI that treats each of the units under its command as part of its action set and train it in increasingly complex situations, such as the two I was able to show you in this video. I'd love to be in this space for the rest of my life. The only major limitation at this point is mostly just an issue with my bank and the lack of any money in it. So obviously, I'm really hoping to earn a spot on a team that has similar passions and start working on solving some real world problems with enterprise level resources. In terms of technical limitations, the most intensive part of this was naturally not the game development or even the coding aspects of the project, but rather it's the sort of art of experimentally iterating between reinforcement learning algorithms, tuning hyperparameters, rethinking the overall architecture, tracking the right metrics, and coming to the right conclusions. I dropped out of law school last year, so I don't have a PhD, but I can read research papers and try out techniques that sound appropriate. If you're here because you're a hiring manager, I hope that SteelRain interests you enough to reach out. And if you're still interested in what I have to say, I have a 3 hour long video essay on this project, which can be found on my channel and will be linked in the description below, as well as a runnable demo on the GitHub. So thanks very much, and please consider reaching out.